Minimal-Pharo on the GemStone VM. But before we get to that, I'd like to give a brief introduction to GemStone, the Smalltalk environment. So here is our agenda for the morning. The traditional Smalltalks that you will use will have an object space or image that is limited to how much can fit into memory, or virtual RAM. The object space is limited to one virtual machine, one process, one single-threaded environment. And sharing objects between virtual machines is a challenge. You can file things out in different formats and then file them back in, but when they come back in, they may or may not have the same object identity. And when the VM exits, unless you save your image, you will lose the state for the objects. With GemStone, object space is limited by disk, not by RAM, and so this can be terabytes of space spread over multiple disks. The object space is shared across multiple virtual machines on multiple hosts. So you can have thousands of machines, thousands of virtual machines on thousands of hosts. And we have transactional persistence. So if you commit a transaction, then once you commit, your data is persisted and safe, even if the machine crashes. This is handled through an architecture that has a number of processes running. And so we have on the right-hand side some server processes, and on the left-hand side some application processes, session processes. I'm going to describe those a little bit more in detail. We can have different types of gems. One is a linked gem, the other is remote procedure call, or RPC gem. With a linked gem, everything exists in one application space. Your application and the GemStone virtual machine. With a RPC gem, you load the library into your application space, but then communicate over a socket to the gem that is in a separate process space. That gives you a number of options for configuration for the machines. So we can have a single machine with linked, and so here we have a process that has your application and the gem, and then on the same machine as the stone and the rest of the system. You can have a single machine with the application and the gem in separate processes. You can separate them over a network so that your application can run and communicate over the network to the gem server. Or you can configure your machine on your application on the same machine as the gem and have a network over to the rest of the repository. You could insert a network here, so we can have three machines. The client application talks to a gem that is running here, and then that talks to the repository, the stone that's running on a third system. So we have a number of configuration capabilities. There's a shared page cache that is used to bring into memory frequently used objects or recently used objects. So even though you have an image that is terabytes in size, you can bring just part of it into memory. So that describes briefly the GemStone architecture. We're going to look now at the topic of replacing or editing base class libraries. So why would we want to replace the base class libraries? Well, Smalltalk is designed from the beginning to allow exploration, experimentation with language design. We also would like to be able to run things from a different environment. So one approach to portability is taking something like ANSI Smalltalk. And if everything were ANSI at the bottom, then portability might be a little easier. We have a grease layer that is particularly useful for Seaside and other things that build on. But the question is, can we go lower? Can we have a different base class library? So what I'm showing here this morning and discussing is one approach to doing this. This is not the only approach that would be taken in GemStone, but this is one approach just for exploration of an idea. So I'm going to discuss 4 options as to how GemStone might support this and work our way to the one we choose. One idea is complete replacement. Just replace everything, all the base classes, from the ground up. In most Smalltalks, that would not really be a serious option because you have to have something in your image in order to interact with it. So things like creating methods requires execution of code. GemStone actually has the capability of schema editing through a C API. And so you can actually install methods without executing Smalltalk code. So this would be an option, but to do that, it would be very difficult to debug what you're doing because you have nothing in there to deal with the environment. Another challenge is that the virtual machine still knows something about some of the core classes and their schema. So complete replacement is not a particularly attractive approach. GemStone has a namespace model that allows you to have parallel hierarchies of classes. So let's take a look at what it would mean to use this namespace model. To understand it better, think of how Pharo and other Smalltalks have a namespace lookup. You start with your image, there's something in your image, an instance of Smalltalk image that's bound to Smalltalk. It has globals, there's a system dictionary that is your dictionary of key value. And with that, we have associations that bind symbols to objects. So in Pharo and many Smalltalks, you can only have one key for each name, one object per name. GemStone takes this and says, instead of starting at the top layer as a Smalltalk object, we have a list of users. And these users have a user profile. Each user profile has a symbol list. Each symbol list is an array of dictionaries. And then for each dictionary, you can have key value collections. So again, multiple users. Each user has multiple dictionaries. So here, let's say we have 2 users, Bob and Carol. Bob has a symbol list, and Bob's symbol list, the first entry in Bob's symbol list is something we call user globals, where Bob would keep individual, local, user-related data. Then Bob's symbol list continues. The second entry is something called globals. The third entry is something called published. Carol also has a symbol list with user globals that are unique to this user, and globals and published is shared. So these are symbol dictionaries that are in the symbol list for respective users. Some are shared and some are unique. Within this environment, Each dictionary is again a collection of associations. The associations have keys and values. Two symbol dictionaries can hold the same association. Another dictionary could hold a different association that has the same key and the same value. So we have different paths to come into this same arrangement. So you could get to the array class through Bob's user globals or through globals, and this association takes you there, or Carol's user globals can take you into this. We can also have unique keys. So for Bob can get to globals and association. A key named array can point to the class named array. For Carol, in her user globals, she can have an association where the key points to list and the value points to array. So when this user resolves a global named list, you could say list new, and that would give you a new array. We can also have similar names that point to different values. So again, in globals, there's an ordered collection that points to one class, ordered collection, but there can also be another association with a key of ordered collection that points to a different value of ordered collection. So two users can see different classes. So, but we can create different classes with different hierarchies. There's a couple challenges with this. Literals are known to the virtual machine as well as some other things. So if in your code you say pound or hash, paren, the compiler will generate a literal that references an instance of the class array that's known to the compiler. So we lose the ability to have a completely separate array class through this. And there's a number of other things that have a similar problem. So there's some other classes behavior. When you send message not understood, that's sent from the virtual machine. Block closure and so on. So these are challenges. So we want to be able to have different implementations of print on in array. So in Pharo, print string gives us this string. In GemStone, print string gives us a different string. And we have to use the same class, but we want to have different methods. So in GemStone, we have a capability of creating parallel method hierarchies. So not only can you have parallel classes or globals, we can also have parallel methods. And so each GemStone class has not one method dictionary, but a collection of them. And this is an array that's ordered by actually a zero-based integer, where 0 is the GemStone implementation. We added this feature for maglev to support Ruby, but there are many others available. And so I'm going to use method dictionary number 2 for Pharo. So how does this work? Well, again, in Pharo or traditional Smalltalks, you would have a hierarchy of classes, and each class has one method dictionary. And there's a lookup chain. So we start with array in this method dictionary. If we don't find what we want, we go to arrayed collection, and then we go up to sequenceable collection, and so on up to object. In GemStone, we have array, which inherits from sequenceable collection, and there are multiple method dictionaries. Method dictionary 0 points up to the sequenceable collection 0. whereas method dictionary 2 can point up to a different method dictionary 2. But notice here we don't have arrayed collection in between. And we want our method dictionary 2 to inherit from arrayed collection. So GemStone gives us the ability of inserting method dictionaries into the lookup chain. And so while formally, technically, array inherits from sequenceable collection, our method dictionary 2 can have in its lookup chain a method dictionary 2 for arrayed collection. So now we have inserted a new class to inherit. So in environment 0, if you said 1, 2, 3, print string, you'd get this. In environment 2, if you said array, print string, you'd get something else. And so it depends on where you're sending the message print string. You can send it from one environment or the other, or you can actually explicitly ask for a particular environment. So this is a syntax in a message send that says, for this selector, send it in, look up this selector in environment 0, or look up this selector in environment 1, 2. So array has a collection of method dictionaries, and one of them has a GemStone implementation, and the other has a Pharo implementation. So this gets us further, but there's still a few problems. GemStone classes might have a different schema. And so if you were to use only GemStone classes with the second method dictionary, you would run into problems with things like ordered collection, because the Pharo methods expect there to be array, first index, last index, and there isn't. So ordered collection is, we can't use the GemStone ordered collection. But this isn't really a problem, since ordered collection is not one of the classes that's known to the VM. We can actually take a hybrid approach. So option 1 was replace all classes, but we don't want to do that. Option 2 is use parallel classes, but we can't do that because some are known to the VM. Option 3 is use the existing classes to parallel methods, but that doesn't work for some of the classes. So we're going to use a hybrid of, we're going to use the GemStone classes when necessary, and then we'll use the parallel classes otherwise, and use environment 2 for everything. So GemStone has this. We need, in order to actually use it though, we need to interact with it through tools. GemStone has a native tool called Topaz. Then there's GemBuilder, which is the IDE that's very powerful for VA and VW. There are other tools that exist. Toad is something we'll see and hear more about. And then there's something we're going to hear in the next presentation about the Glamour toolkit. And then Jade is something that I have been working on for a while. And so I'm going to show how Jade will interact with this environment. There's still a few issues, and there's a lot more details. This is just a little bit of experimenting. There's some things that GemStone just doesn't support. Pharo has 32-bit objects as well as 64-bit objects. Pharo has weak references. GemStone has ephemerons, but not the true weak references. And GemStone's compiler is in the virtual machine. So that limits some of the ability to experiment with just editing the compiler, which in many Smalltalks is part of Smalltalk. So with the demo, we're going to look at a few things here. And we will start out by bringing up this and going into preview, and then starting this up. So here, we're going to take the Pharo minimal image, and with that minimal image, you'll see that it's really not as minimal as we'd like. There's many packages, and so, but it's still what they call the minimal image. So we're going to take the Pharo minimal image. We're going to take the GemStone 64-bit 3.4, and we're going to take something called Pharo GS. This is a GitHub project that Dale started. I forked it on GitHub and am trying out some things by putting in various experiments, including a script that goes into Pharo, extracts the globals, pools, classes, methods. So we're going to run that script, and it's going to pull out of Pharo globals, pools, 1,400 classes, 25,000 methods. Then we're going to go into GemStones, initialize a base extent that has only the base core GemStone code in it. That will start up our GemStone environment. And then once that's running, we'll go over to our shell again. You'll see that it's running, it's got processes, PIDs, and so on. Then we'll go back to our shell and we'll set up GemStone. And this is going to install globals, pools, classes, methods, and the methods take a little while, then we'll do some other cleanup. And then we can go log in with GemStone, open a class browser, look at the dictionaries. Globals is where GemStone dictionaries live. And so you can see all the familiar GemStone globals, if you're familiar with that. But we've created another dictionary named Smalltalk. And the Smalltalk dictionary is the place where we put the Pharo classes. So if you scroll through this list, you may recognize some things that are unique to Pharo. This is different, but we are using tools looking at Pharo classes. We can specify environment too, and so now Pharo has its classes and methods. And in GemStone, we have the array, class, and methods. And in Pharo, we have the array, class, and methods. And it's the same class, but different methods. So we'll go look. GemStone doesn't have print on, but it's implemented in collection. So here's the implementation of print on, and then we'll switch over to Pharo and look for the print-on method there. So we have a different print-on implementation. In GemStone, if we say 1, 2, 3 print string, we get the GemStone print string. But we can open up a new workspace and specify this is going to be a workspace in environment 2, and say 1, 2, 3 print string, and print it. It gives us the Pharo print string. How does this look? We also have tools for debugger. So I can take the GemStone debugger and run it against the Pharo code. I can even edit code in the debugger, save, and continue with stepping into the various Pharo code and method. So we can step through, look at the code in the debugger. If we get a walk back, we can edit the code, make corrections, read the code, but we don't have a debugger implemented in Pharo. We're using the debugger tools that are implemented in GemStone. So we're using a full, rich, mature set of tools to work with a brand new set of class libraries. We can go in and look using method pragmas. I can say, show me all the methods primitives. And with that, we get this list of, well, there's, and actually I think there's something like 1,000 of them. But so this is still a non-trivial project to go in and work with each of the primitives and find out how this needs to be implemented in GemStone. But in many cases, it's a matter of substituting a different primitive number, and then it will call the VM. So that shows us a demo of it.
5 minutes.
Yes. And with that, we have an opportunity for some questions. Yes?
Sure. So you support Seaside in GemStone today.
We support Seaside and GemStone today.
Would the motivation be to support Seaside in a Pharo running on GemStone, or to trying to keep up with Seaside changes, being that their reference platform is Pharo?
Okay, so motivation. The motivation for, I should let, Dale's the one who started the Pharo GS project. So I'll let him, before he answers that, though you can stand up and get ready to say, my motivation is to have a talk to show at ESUN. And so I'm done with it. Dale.
Okay,
Yes.
So the motivation was that, when you port a Seaside application that you've developed in Pharo to GemStone, it's very likely or possible that you will be using Pharo language constructs or Pharo methods. And right now, we have a compatibility layer in GemStone that Seaside runs on top of. But your application may use other methods and other things that are supported in that compatibility layer. So the motivation is to just simplify. It's much easier to sit down and not say you have to port your application to run on GemStone, but just move your application to GemStone. So that's the real motivation, the idea of, if we can get to 100% compatibility, that would be great. If we can get to 85%, that would be good.
And I will also say some of my motivation is just show off the fact that GemStone has some features that allow you to undertake these sort of projects. So I think that there's cool features here, and Dale was talking about this, and I asked him if he was presenting it, and he said he had something else he was presenting, and he said I could experiment with this and show one approach to it. I think if this does go further, there may be quite a different approach taken to it, but it will use some of the same constructs of dictionaries and methods.
Will it be possible to open user interface? For example, block is based on FFI codes, and GemStone doesn't support FFI.
GemStone supports FFI. Martin, I think 2 or 3 years ago at one of these conferences, gave a demo where he called some xlib code and opened a window from GemStone. So yes, anything is possible. It's software. But the devil is in the details. So that's all the time. I am enjoying being here. I love talking about these technologies, and I would be delighted to visit further with anyone who'd like to discuss this or other GemStone Smalltalk